All right, welcome back to lesson 4, roots of a function or zeros of a function. Roots and zeros are the same real concepts. It's just two different ways to say the same word. So our goal today is that you're really going to be able to find the roots or zero of any function when you're given a graph or when you're given an equation or even using your graphing calculator. So you've got 3 different ways to identify those roots and zeros. And if you remember back from the vocabulary section, roots and zeros are just where it crosses the x-axis. So this is what we're looking at, is where does your line, where does your function cross that x-axis. So, and that's really what we're talking about. So if you take a look graphically, we're looking for these 2 points right here, the one right here and the one right here. That's where it crosses the x-axis, and that's our root. So in this case, if we're looking at this equation or with this equation here or this picture, you would say the roots are -2 and 2. Okay. Algebraically, it looks a little different. You set the result of the function, the f of the x, equal to 0. So you say y is equal to 0. So you take this equation and substitute 0. So now you solve for x. So it tells you where does that cross the x-axis. So like you'd see, you'd add 8 to both sides. You get 8x, 8 equals 2x, and then divide both by 2 to get 4 equals x. And that would be your root for that one. You can have as many roots of the equation as you do exponents on the x term. So if I have an x to the 4th or an x to the 3rd, I'm going to have 4 roots and 3 roots. If I have x to the 1, I'm just going to have 1 root. So first thing you got to do is just be able to take a look graphically. And if you take a look, so we're really going to be able to identify, okay, here's the root of this function. So you'd say the 0 of this function is equals +2. You'd say over here the zeros of the function, in this case there are 2 zeros, would be right here at -2 and +1. So you'd say -2, +1. And then over here you'd say, okay, here's one root, my root is at 4, and my other root is at -3. So -3 and 4 are my roots in this case. So, and these are all just different types of functions you have on the circle on number 3 wasn't a function, but the rest of these are. Okay? Take a second and look at these 3 and do 4, 5, 6 in your notes, and then we'll come back and we'll check them. All right, so you can see in this case, the roots over here, we're going to be at -3 and +3. Over here was at -1 and 5. And then over here, you're going to see, okay, here's a root. Now there's 3 roots in this case. So we have 1 root at -5, 1 root at 0, and 1 root at +3. So you have 3 roots. This happens to be a cubic function, x cubed. It's an x squared function, and this one's actually an absolute value function. We'll take a look at that x squared quadratic function later on. All right, so now let's take a look and jump into solving it algebraically. And this is the exact problem I had in the example earlier. So the idea is that you're going to set the result of this function, f of x, and you're going to replace it with 0. So one of the things we learned back in a previous lesson was that f of x is the same as y. They're equal to each other. They're just another way to write the function of x, or the result of x is y. Okay? So if I plug that in, I'm basically asking where y is 0. So if you take a look at this coordinate plane, this is where y equals 0. What is x? So to do that, I set that function equal to 0, and then go for x minus 8. And now I solve for x. So I'm going to add 8. So I'm going to 8 equals 4x. I'm going to divide both sides by 4. And now I'm going to get 2 is equal to x. So my root of the function is at 2. Okay? So I would have a function root somewhere right about there, something along those lines. So we can do the same thing throughout all of these. The key to remember is to set the root equal to 0, that f of x. So we'll do these 2, and then we'll give you 2 to practice on your own. So now if I say -x plus 7, so there's a trick to this one, though, so I'm going to have it. So we subtract 7 on both sides. This part's the easy part. -7 is equal to -x. And I don't want the -x, I want the actual x. So if you'll remember, there's always a coefficient in front of that x of 1, so we're going to divide by -1. So this time 7 is equal to the x, so there's our root algebraically. Now over here we got a fraction. Doesn't change the way we do our problem. We're going to subtract 2. We're going to set it equal to 0. 1 half x plus 2. We're going to subtract 2 from both sides. So I get negative 2 is equal to 1 half of x. Use my reciprocal to solve the problem. So I get negative 4 is equal to x in this case. All right. So that gives us those two problems. Now the last one is using your calculator. This really allows you to use that TI-84 plus something you have. Okay, and you'll notice in the top left-hand corner, you'll see this button of the calculator. It's y equals. And that's where you actually go to graph all of your work. So you'll actually type this in. Now you don't have to worry about this right here. You're just going to use y. Okay, so it'll just say y equals, and you're going to type this in. So you did x and the square key minus 16. And then on the other right-hand side of your calculator, on that same top row right below the screen, it says graph. When you hit graph, you get a function, you get a graph that looks something like this. Now, this is from Google, but it's the same idea. But you can now see quickly, okay, my 1, 0 is at 4, and my 1, 0 is at negative 4, and 4 are my roots of that function. Okay? All right, so now it's time for you to practice a couple. Okay? So we'll like you to type these two into your calculator. You can type one in at the same one and then clear it, or you can go one and then you can go to the next one. You have multiple colors on your calculator. You'll be able to see the difference of the two zeros and come up with the zeros. So go ahead and pause the video and then answer the multiple choice question of where are the roots of these two. All right, so as you can see, I've got my graph calculator right here. So my roots are at negative 6 and 4. And on this next one, you can see my roots are at negative 4 and positive 7. Okay, we'll really be looking at another way to find these later on in the semester. This is a lot of what we talk about with Unit 8. A lot of what we're talking about is zeros. Actually, this is going to tie back into Unit 8, Lesson 6. So let's try now. These are cubic functions. These are x cubed. Okay. So I'll go ahead and show you the first one. And one of the things that you're going to find that's really neat is since there are 3 x's, you're going to happen to have 3 roots. A root at negative 1, a root at positive 2, and then a root at 4. It's still a function. That's what the f of x stands for. But it gives you those 3 different roots. Now I'd like you to type this one into your calculator and see what you get as the roots of that function. Go ahead and answer that question. And now that you've got that typed in and checked it, you can see that the root of that functions we're going to be at 1, at 0, and positive 1, negative 1, 0, negative, positive 1. So the last part of the lesson, it comes into how can I use this phrase? How can I use words to describe what I see on that graph? How can I explain that to somebody? And really what you're looking at are using these terms. We've looked at all these different terms in previous lessons. We added this one today. But we've talked about discrete or continuous. And remember, discrete means dots. Helps you remember. And continuous is a line. So you can definitely tell this one is a discrete graph. Okay. And it has a range. Now we're going to look at domain. Domain is your x value. So you're going to say, okay, it starts at negative 3. So my domain is from negative 3 all the way up to, but there, if this was continuous, you'd say it that way. But since we're using a discrete graph, we're going to say, okay, my graph is, my range is going to be negative 3, negative 2, negative 1, 0, 1, 2, and 3. And you put this in paragraph form. Then I say my range is going to be from the same basic range from negative 2 to 1, sorry, negative 1. And then 0, 1, 2, and 3. Those are my ranges. My function, the vertical line test, this is not a function, okay, because it fails, CTION, it fails the vertical line test at y is equal to 0, so it fails VLT at y equals 0, and it does have 2 zeros of the function. It has a 0 at negative, or at 0 and positive 1. So those are all the different things you would be able to tell me by using this graph, and that's what you're going to do in person. And that's one of the things that's on your homework. This is the one that's in your notes. I've already went ahead and posted the copy of the answer key of this particular section written out in full out type version so you can see what it looks like. And then I've got one more if you want to practice talking your way through this particular graph. So you can say this one is continuous, its domain is all real numbers, so is its range, passes the vertical line test and has 3 zeros at -1, 0, and 2. And those are what you would write out in any long-term phrase. So now you're all set to jump in and do lesson 4's homework. If you have any questions, feel free to reach out and we can work on it.